Okay, in the last part of chapter 5, 5.8, we start talking just about 30, 60, 90 triangles. So 5.8 is really split up into two sections. A part that talks about 45, 45, 90, which we talked about yesterday, and then 30, 60, 90 triangles. And we already talked about why 45, 45, 90 triangles are so special. Today we're just talking about 30, 60, 90. So again, just like with the 45, 45, 90 triangles, you can always use Pythagorean's theorem. So if at the end of the lesson you really don't understand what's going on, please just use a squared plus b squared equals c squared. Just use Pythagorean's theorem, it's fine. Now, let's say I tell you that this triangle, this is 30 degrees and it's a right triangle. This one has to be 60 degrees because of the triangle sum theorem. All the angles add up to be 180. Now, if you look at it in terms of, if I added another one on, rather, okay, let's say I add another 30, 60, 90 triangle to it. What kind of triangle does this make? Well, it makes an equilateral triangle. And so that means that if this side is going to be, let's say it's 4, that means that this whole side would also have to be 4, and this side would have to be 4. So looking at the original triangle that I drew, how long would this side be? Well, that would be 2. And then we could do Pythagorean's theorem to figure out how long this side is. So I'm going to ignore these again. I'm going to erase this. So in 30, 60, 90 triangles, the first thing I want you guys to notice is that the shorter leg is always half as big as the hypotenuse. Or you can say that the hypotenuse equals 2 times the shorter leg. We put short. Okay, that's one thing you need to notice is how it happens in every 30, 60, 90 triangle. Okay, so now we're going to do Pythagorean's theorem. This is the long way to figure out how long the longer leg is. So we can say, we'll call this x. So we know it's 2 squared plus x squared equals 4 squared, and then that would be 4 plus x squared equals 16, and then subtract, and we get x squared equals 12, and then we have to do the radical. And what do we have to do with the radical? We have to simplify it. So that would be, let's see, 2 and 6, and 2 and 3. Here are the couples that go out. Here's the loner that stays in and does geometry homework. And then that's what x equals. Okay, so if you notice something, this number and this number are always going to be the same. All you have to do to get the longer leg is multiply the shorter leg by radical 3. So, okay, this is a shortcut we're going to write. We're going to write that the longer leg equals the radical 3 times the shorter leg. Okay, so here are two shortcuts that I want you guys to write down. Again, if you don't remember these, you can always do Pythagorean's theorem. Okay, so let's try that. Okay, so number 1, they give us the hypotenuse. Remember the shortcuts we're going to try to use. If you don't want to use them, that's fine. But one thing you've got to remember is just for 30, 60, 90 triangles is that the hypotenuse equals 2 times the shorter leg. So if this whole thing, that's the hypotenuse, if this is 22, what does x have to be? X is going to be half of it. 22 divided by 2, x is going to equal 11. So that's one answer. Okay. Well, if you can do that, if you can do this first step, then you can do Pythagorean's theorem, it's fine. So 11 squared plus y squared equals 22 squared. Go ahead and solve it. I guarantee you you're going to get 11 radical 3. Because the second part of the shortcut is that the longer leg is radical 3 times the shorter leg. Okay, and if you don't believe me, do Pythagorean's theorem. But that's what the shortcut says. Okay, so for number 2, the hypotenuse is 24. So what you're going to do is you're going to divide it by 2, and you're going to get that the shorter leg is going to be 12. Because this is half of an equilateral triangle, right? So this side has to be 24, and this whole side has to be 24, meaning that this side's only 12. All right, so we got one answer down. Now I want to know what y is. We can do Pythagorean's theorem if you want to, and in fact, I'll do it with you. So 12 squared plus y squared equals 24 squared. And 12 squared is 144. And 24 squared is, oops, I put the 24 squared is 576. And then we subtract, and we get y squared equals 432. And then we have to do, I'm going to move it over here a little bit, we have to do the factor tree for 432. Goodness, this could take a long time, which is why the shortcut is nice. So we have 2 and 216. We have 2 and 108. We have 2 and 54. We have, let's see, 54 divided by, what's it, 8? No, 9. 9 and 6. And then we have 3 and 2, and we have 3 and 3. So are you guys seeing, this is can be a long process, so doing the shortcut would be nice. All right, let's get all of our pairs together. There's a pair, there's a pair, and there's a pair. They're doing long distance dating. There's a pair. Okay, so we've got one pair of 2s, one pair of long distance 2s, one pair of 3s, and then we've got the loner, radical 3. All right, so 2 times 2 times 3 is 12 radical 3. Okay, so again, what the shortcut is, if you know what this short leg is, all you have to do is multiply it by a radical 3. That's it. Okay? I want you to do me a favor and try to do number 4. Should be able to do number 4. I'm going to check it in class. Okay, so I'm going to give you some harder questions now. I'm going to do number 3 with you. 3 is harder because there's a radical in there already. So some people are like, oh my gosh, what do I do? Well, don't freak out first and foremost. What we're going to do is we're still going to do the same thing. We know that if this is the hypotenuse, all you have to do is divide it by 2, and that's going to be what x is. That's going to be what the shorter leg is. So with radicals, remember, you can't combine a whole number and a radical. So if you look at both of the whole numbers, you can simplify that, and you can say that 9 is just going to be 9 radical 3. So 18 divided by 2 is radical 3. Is 9 radical 3. Okay? So that's how you get x. You're just dividing the whole numbers by 2. Now to get y, remember the shortcut, you could do Pythagorean theorem, that's fine. The shortcut though, is now that we know what the shorter leg is, so first thing we did was we took the hypotenuse and we divided it by 2. Second thing we did was we're going to take the shorter leg and we're going to multiply it by radical 3. That's what this says right here. That's what this shortcut says right here. A shorter leg is 9 radical 3, and we're going to multiply it by radical 3. Now I think we've already talked about this. What happens when you take a radical 3 and you multiply it by itself? The radicals are going to go away, and you're just going to be left with a 3. And so we have this 9 times 3, and it's going to be 27. Okay, so just like with the 45, 45, 90 triangles yesterday, remember I said there should be a radical somewhere? There should also be a radical somewhere for the 30, 60, 90 triangles. For a 45, 45, 90 triangle, whoops, 45, 45, you're going to have a radical 2. For a 30, 60, 90, you should have a radical 3 somewhere. And how I remember that is there's a 3 with the 30. And how many 45s are there in a 45, 45, 90 triangle? 2. So that's one way how you can remember the difference between the radicals. Okay, I'm going to pause this video, and the next video will explain to you how to do 5, 6, and the rest.